Hey, Algebra 1, we're going to be jumping into Module 1, Topic 2, which is all about sequences. The main idea of sequences is that you're given a list of numbers and there's some type of pattern between them. If it's arithmetic, that means it's going to be some pattern of addition or subtraction with the same number over and over and over, making it feel linear. If it's geometric, we'll see more of multiplication or division in terms of getting to the next number, and we call that geometric. So let's jump into it. The first thing you need to understand is it says determine the common difference for each arithmetic sequence. So if it is arithmetic, they have some value that is in common with adding or subtracting to get from one number to the other. So for example, number 3, I'm going to be finding the common difference by taking the second number and subtracting the first number. So 13 minus 10.5 is 2.5, and that means that to get each additional number, I am adding 2.5 to the previous number. So 13 plus 2.5, that's 15.5. 15.5 plus 2.5, that's 18, so forth and so forth and so forth. Number 4, it's got some fractions, but same idea, the second number minus the first number, 2/3 minus 1/3, that would be 1/3. And so it may be hard to see, but you are really adding 1/3 over and over and over. 1/3 plus 2/3, that'd be 3/3, which is 1. And if you add another 1/3, that makes 4/3, then you'd have 5/3, and it just keeps going on in this linear way. So I'll do one more with you. Say number 1, I'm trying to find that common difference. So 5 minus 1 is 4. So basically I am adding 4 over and over and over. And maybe if I do number 2, that'll help you as well. This one's going down, and that's why you should see more of a subtraction idea. This is subtracting 7 over and over and over. So every time you see the next number, it's the previous number minus 7 to get you the next number. So give number 5 and 6 a shot, subtract the second and the first number, and you should find the common difference pretty quickly. So let's say you use that same concept to figure out the next few terms in an arithmetic sequence. So again, arithmetic means that the pattern is linear. It's more adding or subtracting some common value. And so I'm going to do 3 and 4, some of the harder values, and you can try 1 and 2. I'm going to take that second number and subtract that first number. 4/5 minus 3/5, well, that's 1/5. So what we're seeing is that it's really adding 1/5 over and over and over. So 1/5 plus 6/5, that would make 7/5. Add another 1/5, that'd be 8/5. Add another 1/5, you'd have 9/5. And that could just keep on going and going and going. The next number is going to be 2, because that would be 10/5, which would be 2. Number 4, I'm going to take that second number and subtract the first number, and that gives me 4.5. So that means that in this sequence of values, you are adding 4.5 over and over and over. So 25.5 plus 4.5, that would be 30. Add 4.5 to that, you'd be at 34.5. And add 4.5 to that, you'd be at 39. So we're just trying to find the next 3 terms by first using this formula on the first page, the second number minus the first number. That tells us the common difference that we need to use with adding or subtracting to find the next few terms. So that's all about arithmetic. Next we're going to talk about geometric sequences. Geometric is not adding and subtracting. It's more like multiplication or division. So let's look at number 1, I guess, trying to start it out. Instead of subtracting the second and first number, I more want to use division. Because if you think about 10 minus 5, it looks like, yeah, it added 5 the first time, but it does not continue to add 5 to get the next few numbers, and that's how you know it's not arithmetic. But if you do 10 divided by 5, you see that really in this pattern, you are multiplying by 2. 10 times 2 is 20. 20 times 2 is 40. 40 times 2, that next value is going to be 80. So I'll do a few more with you. Negative 30, that second number, divided by that first number. This one's multiplying by -3. That's that common ratio. We use the word ratio with this because ratio has to do with multiplication and division. We're basically multiplying every value by -3 to get the next number. So let's try one that is decreasing, because a lot of students see this as division, which is fine. 15 divided by 45. If you think about 15 divided by 45, that's really a third. So you could say, yes, I am dividing by 3. Like, for example, 45 divided by 3 is 15, or 15 divided by 3 is 5. But the truth is that we're multiplying by a third. For example, in the calculator, 15 times 1/3, that's how I'm getting 5. So that's very important in understanding when you build the equation, which we'll do in a minute, that you really need to use fractions to represent the numbers that are dividing. Next, determine the next 3 terms in each geometric sequence. We're going to start out by dividing those numbers because we want to know that common ratio. So let's start by saying 9 divided by 3 would be 3. And this tells me what number I am multiplying by over and over and over to get the next few numbers. 9 times 3 is 27. 27 times 3 is 81. Let's take a moment to do 81 times 3. 243. Multiply that by 3 to get 729. And maybe one more time, let's multiply that by 3 to get 2187. So again, these are geometric because they have a common ratio between them. You may start by subtracting 9 minus 3. It may look like it's adding 6 that very first time, but it doesn't continue doing adding 6. And that's why you have to lock in more on multiplication. So number 4, I'm going to take that second number and divide that first number. And again, this is giving you a fraction 1/10. So you can think about it as dividing by 10. That really is the same thing. But technically, you are multiplying by a tenth. So if I continue this pattern and multiply 3 times 1/10, well, I get 3/10. And if I multiply that by 10, that could be kind of difficult, but really that 10 in the bottom gets multiplied by 10 to give me 100 in the bottom. And then 3 over 100 times another 1/10, that just makes that denominator 1,000 now. So if you don't like that, we could multiply 3 times a tenth in the calculator and just make sure that you are changing that to a fraction. That's in simplest form. Let's multiply that by a tenth and just keep seeing what I'm talking about. When you're multiplying by a tenth, that denominator is what's getting multiplied by 10 over and over and over. So try the other ones I didn't do and check your work with your teacher. So now it says determine whether each given sequence is arithmetic or geometric. So you really don't know, am I adding every time or am I multiplying or dividing every time? So what I like to do is I like to start by checking if it's arithmetic by subtracting the first 2 numbers. For example, 8 minus 4 is 4. Or I could say, well, 8 divided by 4 is 2. So the question is am I adding 4 every time or am I multiplying by 2 every time? And so, yes, 4 times 2 is 8, but 8 times 2 is not 12. This is more of the first one. You are adding 4 to get to the next number. So I'm going to call this first one arithmetic. On the second one, I can start by saying, and I've got my numbers messed up here. I apologize about that. I need to do the second minus the first. So 8 minus 16, that would be -8. That suggests that I'm subtracting 8 over and over and over. Well, that works the first time. 16 minus 8 is 8. But if I do 8 minus 8, that's 0, not 4. So I don't think we should think of it as arithmetic. However, if you do 8 divided by 16, that is a half. And that is what's happening over and over. You are multiplying by a half to get the next number. 16 times a half is 8. Half of 8 is 4. Half of 4 is 2. So this second one we need to call geometric. But again, make sure you're doing the second number minus the first number. You saw that I messed that up for just a moment there. That will help you find either the common difference or the common ratio. So next we're going to talk about explicit formulas, how to build a sequence formula that would generate these sequence values. So I need to start by the formula. The first number is a sub 1. That's the first number in the sequence. That's what I have in blue. And then we need to know that common difference for arithmetic sequences. And then I also have n minus 1 as a part of the formula. So for number 1, we're going to start out by saying, well, the first number is 1. 4 minus 1, these have a common difference of 3. And then I want to distribute that 3 into that parenthesis. And then 1 minus 3 will clean up 3n minus 2. Well, I now want to calculate the 20th term. So I want to replace n with the number 20. 3 times 20 would be 60 minus 2, 58. So that 20th term in the sequence is going to be 58. And I don't have to list out all the numbers to know that because I built a formula, and that formula is 3n minus 2. Let's do another one by hand together. The first number is negative 10. If you subtract these negative 15 minus negative 10, this ends up giving you negative 5, and that's why these numbers keep getting further and further negative. So I want to distribute that negative 5 next to get negative 5n plus 5. And then I want to combine like terms on the edges. Negative 10 plus 5, that gives me negative 5. So now I have a formula for generating any number in the sequence that I want. So if I want the 100th number, make it 100. Well, I want the 30th number. So negative 5 times 30 minus 5. This ends up giving you negative 155. If that went a little quick, back the video up and watch it a little more. Let's do another one that could be a little challenging. I'm going to show you that you should start by considering what that formula looks like and then replacing everything in that formula correctly. For example, that first number, a sub 1, that represents the first number in the sequence. I want to subtract the second number minus the first number to understand the common difference as positive 1.1. And then I'm going to distribute, combine like terms, and then if I'm looking for some future number, let's plug in 25, n for n. So let's see, 1.1 times 25 plus 2.2, that gives me 29.7 as my future 25th term. Okay. I've got a few more minutes left. Let's go to one that's more geometric. So geometric has a different formula for it, and it can be a little easier. So to build a geometric formula, I start by using the first number in the sequence. I need to figure out what that common ratio is by dividing the second number by the first number, and that tells me that I'm multiplying by 3 over and over and over. And then n minus 1 is your exponent. Let's do that again for this one. Number 9 is my first number. If I was to divide 18 by 9, you see that you are multiplying by 2 over and over and over. And then I have n minus 1 as the power. So for both of these, you need to go back and use a calculator and replace n with the number that it wants you to calculate for that future term. I think for number 4, it's wanting you to calculate the 16th term. So use a calculator to figure out what those values would be, and that can help you understand how to find future terms. So I think I have time for maybe one more of those, one that's a decimal. So again, 0.125, that's the first number in the sequence. If I was to divide negative 0.250 by 0.125, you're going to find out that that's negative 2, and that's why the signs are changing, positive, negative, positive. The next one will be negative. N minus 1 is the power. So again, once you use your calculator to find the next term you're looking for, we're going to replace n with the term you're looking for this problem, which is 20, and then you can use a calculator to calculate that value. Good luck. I hope this was helpful, and I hope you can get a higher grade on your retake. See ya.